So let's talk about different hardware component types. There are many. They can be internal inside of a computer, they can be peripherals, they can be storage devices. We can see here some pictures. We've got a printer that is a peripheral device. Peripheral is anything external that you plug in. Here's some storage. Here's an old floppy drive, actually. Here's a CD, DVD drive. Here is a USB stick. Let's talk about the different network types, just to familiarize you with them. We have this concept called a personal area network, or PAN, and that's really meant for Bluetooth. It's meant to just be a few feet, just around you. It can go as far as, say, a room, but it's meant to be a very, very confined area, like your Bluetooth headset to your phone, or a Bluetooth keyboard to a computer, or your computer to a printer. So it's a very, very short distance, meant to just be just a few feet. Then we have the very common concept called the LAN, the local area network. Now, the LAN actually has very clear protocols that run on a local area network: Ethernet, token ring, in some cases ATM. But with a LAN, we tend to think of a geographically limited location: one office, a building, a campus of buildings. And a LAN, I suppose, could go maybe a kilometer or so, but it's meant to be in a geographically contained area. I was at this one major motion picture studio where the campus LAN actually had an ATM backbone from down below. They had the administration buildings and the sound stages and where they did all the filming and the production. And then up the hill, there was an ATM backbone up to an amusement park area at the top of the hill. And that whole thing was a campus, and they had one whole LAN with an ATM backbone. And they had a whole bunch of different departments and sort of smaller networks inside that entire LAN. And then we have the concept called a wide area network. Now, a wide area network is basically a network of networks. And so what you do is your LAN is connected via a WAN link to another LAN, or via a WAN link to the internet. And so then a WAN can cover the whole world, it can cover a state, a province, a country, a continent. It depends upon how far flung you need your network to go. The ultimate example of a wide area network is the internet. It is a network of networks, zillions, thousands and thousands of networks. And so wide area network. And WANs have very clear protocols. They'll have frame relay, ISDN, PPP, HDLC, ATM. We'll talk a little bit more about some of those protocols when we talk about the OSI model in Chapter 6. Then we have a concept called a MAN, a Metropolitan Area Network. And this is a WAN that spans a limited part of like a city or a region. And it can be, 5 kilometers to 50 kilometers or 50 miles, 60 miles. It kind of depends. A lot of MANs, they can be a fiber ring, or they can be a wireless coverage. And it depends upon how you do the coverage. But they're meant to cover like a municipality or a particular region. And the thing that's really kind of different between MANs and WANs is that generally metropolitan area networks have LAN speed. So like local area networks, I expect the speed of the links to be fast. Gigabit, 10 gigabit depending, 100 megabit at least, maybe the older ones 10 megabit. In wide area networks, I expect more like the link speeds to be more like T1, 1.5 megabits, 1.544, or maybe 6 megabits, or maybe 128 kilobits, much slower than a LAN. But a metropolitan area network, we expect that much higher throughput, 11 megabits, or 54 megabits, or 100 megabit, depending upon the service that you're paying for and the service you're providing. And then there is something here called a SAN, or a storage area network. Storage area network, SAN, is not really for connecting servers or computers or me to a website. It's instead an area of your network, of your LAN usually, where you have boxes for storage. And these boxes have controllers that talk straight to the network, and they can either use IP with TCP commands SCSI commands on top. So we can either use iSCSI or they can have proprietary dedicated fiber type connections. But it's basically so that all the servers in the LAN can have their storage in one specific area that's dedicated just for storage, so that we can have central management of our storage. It's not for connecting from one town to another. Now, it is true that you can have applications send their data and ship their logs and make copies across a WAN link, but that's not what we're thinking of when we're thinking of storage area network. We're thinking usually of a dedicated little network within the larger network, typically a VLAN if it's on IP, or or maybe a fiber channel with special fiber optic cable. And it's specifically just so the servers have storage in a specific location. As we're going to see more in the next module, networking has sets of standards and protocols. Protocols are sets of rules. They're just rules for communication. And we use standard models so that different networking products and protocols and services can work with each other. And so networking standards try to make network products and devices interoperable, more available, more flexible. It's easier to maintain. It's easier to mix and match different vendors. And we're going to talk about some of those network models and standards a little bit more in the next lesson. Let's talk about, in general, different network services. You've probably used all of them, but let's just cover at a high level what they do. Network file system. I'm creating a file, spreadsheet, document, whatever it is. I'm going to save it across the network to a centrally stored location, be it a database or a shared folder or a public folder or whatever it is, so that it is in a central controlled location where we can have controlled versioning and it can be backed up and maintained. So that's a network file system. Email. I'm sending an email to a friend of mine over there. I'm at company.com. She's at training.org. I compose this email. Usually it's actually in an HTML format, even if you're not using an HTML client. My client informs the email server, sends it to the email server that handles my mailbox. That email server looks at the destination and goes, training.org, looks up the email server for training.org, passes it along to training.org's email server, which looks at the destination and goes, you're trying to send this to Sally, and drops it into Sally's mailbox. Then when she starts her email client, like Outlook or Windows Mail or whatever it is, then she goes and grabs it out of her mailbox and it shows up and she reads it. Print services. I need to print something. Now the printer can be connected directly to my machine, or I can submit the print job to a print server, and the print server has a much bigger print queue and a lot more memory and a lot more disk space, and everybody's sending print jobs, and then it can send the actual print jobs to specific printers that have different priorities or different speeds or different papers. I can even do this across a WAN link from a branch office to a central office. I can, at a central office, control all the printers that are at all the branch offices. So print services can be a lot more complex than just simply plugging a printer into one machine. Remote access services. We've actually used remote access even in this particular class, where I'm sitting at one machine, but I want to remotely connect to services or another machine somewhere else. And so I will use either a VPN or a remote desktop or some kind of product or technology so that I can sit here and connect over there. And I can either see a desktop or just connect straight to a server, connect to a database, connect to my email, whatever it is. Directory service, that's a central computer or a central service that authenticates people on the network. So there's thousands of us, and we all have to authenticate onto the network, and our client workstations send our authentication request to a server that holds the directory service and the database. And in a Microsoft network, the directory service is called Active Directory, and the servers that host it are called domain controllers. Network management. I am a I'm IT staff and I want to keep an eye on all the servers. So I'll run a console here and little agents on all the servers, and my console will regularly poll all of the agents. How many users are on you? Any security breaches? How many DHCP leases did you give out? How many queries have you had? Have you had any deadlocks? And then just go round and round and round. How busy are you? Do you have any congestion? Do you have any queues that are backed up? And so it just, in a round-robin fashion, constantly is polling the agents on all of these devices that I am monitoring. And they're not just servers. They could be firewalls, switches, routers. They could be all kinds of devices. And in a central console, I see statistics, which I can drill down into. And I can see problems at a glance. DHCP and DNS, the two really core network services, because all computers have to have an IP address if they're running IP, which almost all networks run IP. They have to get an address. So we can manually type in IP addresses, but that's a lot of hassle. Instead, when a computer boots up, it sends out a broadcast saying, I'm awake, I need an address so I can talk to people, anybody? And a DHCP server, Dynamic Host Configuration Protocol, which you don't need to memorize, will respond by broadcast saying, here's an address. And the client will say, oh, thanks. And the server will log it. And this way we automatically configure clients with addresses. The nice thing about DHCP is that if I take my laptop and plug in, I can pick up an address that's appropriate for the network I just walked into. I unplug, I go home, I pick up a different address for that network. And so I can have different addresses for different networks. DNS, computers want numbers. They want their addresses to be numbers. But humans remember names. So when you type in www.google.com or you type in server1.company.com or something, computers don't care about that. They want to know, oh, it's at 24.1.2.3 or it's 192.168.1.75. DNS, it's just like directory assistance on the telephone system. It's a server that has a database that maps friendly names to IP addresses. As a user, I don't have to know or care. I just type in www.google.com. But in the background, my client computer has a DNS client service that is going to the DNS server saying, do you have an address for this? And there's then a whole system of that server either having the address or going and querying other servers to get the address. So these are very, very common network infrastructure services that you're going to encounter. And as an IS auditor, you need to be aware of all of these services.